So why are we learning this implicit differentiation from 10.5? Here is the application part. What if I wanted some related rates and I want to be able to solve them? So look at what we're going to cover for business is like, what if you're a university student and you're concerned about the rate increase in financial aid is lagging behind the increase in tuition and fees? So you have this financial aid kind of stagnant that's not moving up very fast, but then that tuition and fees is going higher. So those are a related rate that we might want to look at in more detail. Or the other examples they put in here is a renter is concerned that his rent is increasing faster than his take home pay. That's been an issue with teacher pay. In Idaho, the teacher pay is so terrible that like it didn't keep up with your rent at all. Wyoming does pay their teachers fairly well. Still, a little bit lower, but not bad. Way better than Idaho. So the third one, an automobile manufacturer wants to predict how much an expected increase in a car loan interest rates will decrease her rate of sales. Massive for houses right now. The current rate when I'm making this video for a mortgage is like over 7% with good credit, over 7%. My mortgage was 3%, so like 3.1. That tells you how much it's gone up. And that is going to make houses not sell. Same thing with cars. If that rate goes really high, people aren't going to buy a car. So, how are you going to manage that as a business? Okay, so I put an example in here and I walked through the whole thing typing wise, right? Just so you have that. I also went through like a procedure. That's for you. You can read through it. Sketch a figure if you can. Identify your relevant variables, those whose rates are given and those whose rates need to be found. Express all given rates and rates to be found as derivatives. So we're going to do implicit differentiation on them. Okay, and that's what these steps are saying. So problem one is saying, all right, we want to find the derivative given this equals this. If the derivative is equal to 4, x is equal to this. This is a rate, right? So this is saying like a rate of 4. Derivative gives us a rate, a slope. So what is this thing really telling me to do? So we're going to do this in terms of dx dt, which is a little bit tricky. Okay, so when we look at this first term right here, when I go to do that one, I could do the derivative like I see it, right? 2 times 3 is 6. So this is 6x, and then this one is a dx dt. So I'm going to write dx dt. This is the same as like x dx dt. I wrote x twice instead of dt. This is the rate of x in terms of time. Okay, so I am writing the dx dt, the dy dt on every single one, or x prime is like the idea on that, okay? Plus the next one is one that's gonna need a product rule. So I'm going to write it over here. We know our first term is 9x. Our second term is just y. So the derivative of 9x is 9. But what do we have to put next to once we've taken a derivative of an x? dx dt. Or I'm going to use a capital T because otherwise it looks like a plus sign. And that's how we do the derivative with that one. So the same idea with the y. When I do the derivative of the y, I'm going to write it as it's 1, right? So 1 dy dt, because those are different rates. You have a different rate for an x variable versus a y variable. It's a different rate. It's just like if your interest rate is going up, is it going up at the same rate as this other thing? Okay. Okay, so let's times those together. And we're going to have dx times 1 dy dt, or basically 9x times dy dt. And then this way it would be the 9 dx dt and the y. So maybe I want to write that as a y and then the 9 dx dt. Okay, then that's all the just that one term, right? And then the next term is the negative 2y to the third. So I'm going to get negative 6y squared. But again, I have to add the dy dt because it was a y on that one. And then if it equals 0, because it had 15 on the formula and the derivative of 15 is 0. Okay, not pretty, but I can now substitute in all the variables that I know. So I do know 6 times what's x? 2. Do I know dx dt? Or dx dy? Did I write one of them wrong? Nope, dx dt is the 4. Dx dy. 9, 2, 9 dx. Sorry, I was stopped on this right here. Only because I didn't write any of them with dx dy, so it was stopping me for a second. Let me see. I have dx dt, dx dt. How do they assume that is? Oh, they just have a flat typo. Oh, hilarious. Okay, they finally wrote a new version of these. I'm sorry. You're probably like, what is this teacher? Sometimes they have typos, and it's a huge typo. That is a huge typo. Like it stopped me in my tracks. These learning worksheets have so many errors, it's ridiculous. So normally I just do them all myself, which I did, but then it stopped me because it's a dy. Okay, so that is dx dt. So as we move along, this is a dx dt. So this would become 4. This would become 4. And we don't know the dy dt. That's what we're going to be able to find. So typically you can find one of the rates if you know one of the rates or however. So this is going to become a 4 plus 9 times x, which is 2, dy dt, which we don't know. So we're going to keep dy dt there. And then, boom, I was at 9x. Okay, we were here. So then we have y, which is 1. So we're at plus 1 times the 9 that's there. And then we have another dx dt. So that's 4 minus 6 times y squared is 1 squared. And then times dy dt, which we don't know. Okay, equals 0. So we can combine, in between your terms here. So 6 times 2 is 12. 12 times 4 is 48. So I see 48 here plus 18 dy dt plus 9 times 1 times 4 is 36. There's no other terms on that one. Minus 6 times 1 is 6. So 6 dy dt equals 0. And so we can solve now for dy and find that given rate. So I have 2 terms with the dy. So I'm going to minus the 48 over, minus the 36 over. So those are both positive. So what is 48 plus 36? That's 84. So it's going to be negative 84 on the other side. And then I want to take the dy dt out of the other 2 terms. That's going to leave 18 minus 6. When we substitute that out, so 18 minus 6 is just 12. So I'm going to divide that over, and I'm going to get dy dt is equal to negative 84 divided by positive 12, which is a negative 7, I think. Yeah, negative 7. So this is the rate for y. It's kind of a lot of work to get a missing rate, but it's kind of a cool idea. Okay, I can find a related rate in a very ugly way. Okay, so that's one where it gave you each piece. Hopefully it doesn't have a typo. So this problem doesn't, completely different. So a boat is being pulled towards a dock by a rope. If the rope is being pulled in 5 feet per second, pulling it in, and the rope is 3 feet above the dock, so it's above the dock, how fast is the distance between the dock and the boat decreasing when it is 30 feet? Ooh, I need a picture. So I'm going to think you have this dock, right? And you got your boat. How far away is the dock and the boat? 30 feet. Okay, so it's out there. And then we said we are standing 3 feet. Our hands are 3 feet. This may not be to scale so that I can get over the word dock. So this is where I'm standing. That's where my hand is. So that's 3 feet above on the dock where I'm holding the rope, because that makes it different. I'm not bending over and having the rope equal with the dock. Okay. And then this can form a 90-degree triangle. That's nice of it. So that we could find the distance from where we're holding the rope up here, right, to the boat here. So I'm going to call this C because it really goes ABC. And we can find C because C squared is going to equal A squared plus B squared. So 3 squared plus 30 squared. 9 plus what is 30? What's just 9 plus what is 30 squared? I got 909. Oops. So C squared is equal to 909. So C is equal to the square root of 909. I don't care about the negative square root. This is a positive thing. What is the square root of 909? So most of these you could do the decimal. So that's about 30.15. Okay. All right. So goodness. So the rope length right now is 30.15. So if we think of this as A squared plus B squared equals C squared, we'll let the A be the here and the B be here. We could think of this in terms of the derivative. So we're going to actually just take the derivative of A squared plus B squared equals C squared. So that would look like 2A, but then it's really like dA dt. A in terms of time, right? And then the next one would be B, 2B, and it would be dB dt. And the last one, oops, equals not plus, is going to be the 2C dC dt. All right, so I have now done this Pythagorean theorem, and I've done the implicit differentiation. Now let's put in the information that we know, okay? What does A equal? Well, it equals 3. What does B equal? Well, it equals 30. What does C equal? It equals 30.15, or the square root of 909 if you happen to not be okay with the decimal. And then we were given a rate. What rate were we given? A boat is being pulled in a dock. It's being pulled 5 feet per second. Which one refers to the rate of pulling in the rope? Is it dA dt? Is it dB dt? Or is it dC? It's the C, because this is your rope. You're pulling this in 5 feet at a time per second. So our dc dt is going to equal -5. Why is it a negative? Because you're pulling it in closer to you. The rope, you're pulling the rope in. So it's coming in at you, negative. So let's put those numbers in. So 2 times 3, I don't know DATT, plus 2 times 30 times, I don't know DBDT, equals 2 times, I can use the 30.15 or the square root of 909. Sometimes it's better if you use the 909 so that you're not estimating inside of an estimation and stuff. So, and then this is times -5. Okay, let's simplify this kind of out and see what we have. Oh, we can think of one other thing. dA dt. Okay, so one other part, dA dt, that we can think of. So this is the rate here. Am I moving from my dock? Is my dock's rate changing? No, I'm standing there with my rope. So the boat is changing because it's moving in as you pull the rope, which is changing. So we could actually do dA dt as 0. So the dA dt can actually be 0. Took me a sec to remember that, like, basically, like, right, our dock, that part isn't changing, the 3 feet. We're still standing at 3 feet pulling it in. So that's a little tricky. So simplify this, that first part all goes to 0. So I'm gonna have 60 dB dt, and you really should only have one rate left or you can't find the answer. It would be like a function of the rate, but it wouldn't be the actual, an actual number. I'm going to put that in my calculator. So 2 times the square root of 909 times -5. Oops, I put the -5 under my radical. Illegal move. Okay, times -5. Okay, -2 times the square times -5. I got -301.496-ish. Now I need to divide that by 60. I like to just keep the answer in, divide, so that you're keeping the exact or the most rounded you can. So then divide by your 60 on both sides. And so I kept that number the best I can. And the rate in which the boat is moving in is -5.02. So that is decreasing 5 point whatever. It's decreasing 5.02 feet per 1 second. Okay. Definitely tricky. Okay, so the next one is a 30-foot ladder is placed against a vertical wall. Suppose the top of the ladder slides down the wall at a consistent rate of 3. How fast is the bottom of the ladder swinging out for you to smack the ground? Okay, so let's go ahead and draw what we're kind of looking at, right? Your ladder is kind of coming up this way. And yes, I should get paid for these amazing drawings. And this is sliding down and moving this way, right? So this is going down as that one moves out. So those are rates. What is not changing is the length of your ladder. This is a 30-foot ladder, and it will stay 30 feet as it falls, okay? So we start 15 feet above the ground. And do we have a distance? No. So we can find, I don't know, we could call this, if this is A, this is B, this is C, we can call that B. We can find B's distance at the start. right? And then it's gonna shift as it goes. So we can find that again by a squared plus b squared equals that c squared. So a squared is gonna be 15 squared. I don't know what b squared is, and that equals 30 squared. Um, it keeps, I don't think it's blinking for you. My iPad is gonna die, that's why. Oh, let me plug this in. It keeps like blinking weirdly, because I think it's going in and out of low power mode. Okay, so then I'm gonna do 30 squared, and then I'm gonna minus off the 15 squared, so I'm gonna minus that over, and then that's gonna give me b squared is equal to 675, which, so b is gonna be the square root of 675, which is about 25.98. So there we go. We got that number going for us. So we could list off our starting numbers like we did in the last one. A is going to be the 15. B is going to be 25.98-ish. You could use the square root of 675. I don't even care if you reduce it. You can use that full thing if you want. C is 30 feet. And what about dA dt? dA dt. Do I know dA dt? So dA dt. Do I know this rate here? It is consistently falling down at 3 feet. How am I going to do falling 3 feet is a -3. So I do know that that rate, it's falling at 3. Okay, what about dB dt? That's going to be B we're shoving out. Isn't that what we want to know? Yeah, this is what we want to know. We want to know at what rate that's sliding out. How many seconds till I smash the ground? And then the last one is DC dt. Does the rate of basically, is the ladder going to be changing at all? No, it's going to be a consistent 0 on that one. So DC dt, the ladder is going to stay 30 feet, or it doesn't have a rate. It's not sliding down where this distance is getting smaller. It's not sliding out where that distance is getting bigger, right? So one's going down, one's going bigger, this one stays the same. So its rate is 0. Okay, tricky. So if we do the same kind of idea, the derivative of the A is 2A dA dt. And then the next one's 2B dB dt. And the last one is equal to 2C dC dt. Let's go ahead and put in what we know. So we know A is 15. dA dt we know is -3. So we have that one. And then plus 2B is going to be 25.98. Again, you could use the radical if needed. And we don't know dB dt. That's what we want to find. And then equals 2 times 30 for C times 0. So that whole part's just going to go to 0 over there because times by a 0. So then, oh my, so we're going to have -90 plus 51.96 dB dt equals 0. So I'm going to add that 90 over, divide, and I can find dB dt is going to be 1.732. So that is going to be the bottom of the ladder is sliding away from the wall at 1.732 feet per second. So feet per second. Is it sliding feet per second? So if it's 30 feet, and I'm going to think 30 divided by 1.732, 17 seconds for you to smash your face. They didn't ask that. I just am looking at it. Okay, dokey. So all of these are tricky. I'm not going to lie. Problem 3 is like a balloon. Let's skip to 4. Okay, let's just remind ourselves on this one is the volume. Look this up if you don't have it. Of a balloon or a sphere is 4/3 pi r to the third of a perfect ball shape, right? That sphere. You need that volume, and so you can then find the different pieces of that. But we're going to move on to 4 because 4 is relating our business-ish stuff. So it's suppose a company manufactures flash drives, determines that their cost, revenue, and profit equations are given. Determines. Basically, here's their function. Where the production output in week 1 is X flash drives. So X is always our number of items sold. Always. That's the way we set them up so we can be consistent and be able to figure out problems with it. A production increase at the rate of 500 flash drives per week when a production is 2,000 flash drives. Find the rate of increase in cost. Lots of stuff going on. First of all, we are given our cost function. Okay, that's our cost function. And we can see our increase. So if we did the derivative of this, we have dc dt, right? Time, cost, changing cost. So then let's do the 5,000. The derivative of 5,000 is 0. The derivative of 2x is 2, but then it's going to be dx dt, right? So we have our dc dt and our dx dt. What is dc dt? That's your cost increase per week because we're doing weeks. That's our time, our t. So we don't know dc dt. This is what we want to know. What is dx dt going to be? Okay, that's our change in how many items. So our increase in items in production is going to be increase at a rate of 500. So our number of items is X, and those are increasing by 500. So our rate is positive 500. Okay, so we're going to put that in, and I basically can see dc dt is going to equal 0 plus 2 times 500 is 8,000. So our cost will increase by $1,000. So, and that's per week for this one. So it's going to increase. That's our cost will increase $1,000 per week. And the time is always whatever it gave you, right? T is referring to time. We happen to be doing per week. The other one was per second. It doesn't, whatever it's given. Okay. This is all cost. What if I wanted to know the increase in revenue? I don't think cost, it doesn't actually ask that, but I want to do it. So we're going to, they cut this problem off. Wonder why. It's the only one that had to do with, okay. So you could do revenue. So if I did revenue, which is not asked, but we're going to do it anyway, we would think of revenue as equal to, they gave us this 10x, right? They gave us the 10x, yeah. 10x minus 0.002x. Nope, 0.001. I was looking at the derivative. I remember, just kidding, it's a 1. Because we'll times it by x squared. There we go. That's our revenue. So our revenue is always x times the price. The price is typically in terms of demand. So the price is a function that you then have to times x by, okay? Which you did on the Unit 9 project or Chapter 9 project or whatever you want to call it. So here we are. So if we think about what each thing means in terms of what we're looking at, the dr dt is kind of what we want to find. That's a change in revenue for the time, right? And the other thing that we have in here is dx dt. What are we changing in terms of our number of items each week is the 500 again. So it's the same number there. So we're going to do the derivative. It's going to be dr dt is equal to 10 times dx dt. minus 2 times 0.001 is 0.002, x dx dt. And then we have two dx dt's in here. So let's go ahead and put in our numbers. So 10 times the 500 minus 0.002 times the 500. Oh, wait. What was x? Yeah, x was 500, right? I'm not losing it. No, dx dt is 500. It told us somewhere. Okay, up top. Flash drives per week when production is 2,000. That's our X. I was like, wait, I can't put the rate in for X value, right? So this is dx dt. What is X? X is going to be our number of items, but it says the flash drives per week when production is 2,000. So our production is 2,000. That number might be kind of hard to think of. So yeah, our production was 2,000, but we have to times it by the 500 because you have the rate here. So the increase is the rate. Where do we start? That's going to be your X value. You started at 2,000. You plug that all into my calculator. I got 3,000 is my answer on this one. So our revenue will increase $3,000. That's revenue, money coming in, right? $3,000 when we increase by 500. Okay. If we did the profit, it would be the cost, revenue minus cost. So we could do that without doing much. What's 3,000 minus 1,000? Well, it's 2,000. So our profit is going to increase $2,000 per week when we increase by 500 flash drives. We follow all the rules given. Okay, so these ones, like you're going to have to draw some pictures. There's not a ton of homework on it, but each one will take you some serious time. Let me know if you have any questions.